Okay, this set of problems is going to be for 22, 23, and 24. So our situation here is, according to Mars, incorporated 20.5% of M&M's milk chocolate candies made at its Cleveland factory are orange. Assume that the company's claim is true. Suppose you take a random sample of 8 candies from a large bag of M&Ms. Let X equal the number of orange candies you get. Assume that it is reasonable to use a binomial distribution for probability calculations involving X. Now, typically, if you're grabbing from a bag and not replacing it, technically they're not independent. But let's assume the bag is so large that they are independent. We want to know what's the probability you get exactly 3 orange M&Ms. So for this problem here, the probability of getting orange is 20.5%. So it's going to be 0.205. So binomials have a binary outcome. You either have what you want, success, or what you don't want, fail. So success would be the orange, which means fail, probability of not orange, is 1 minus that. Which is going to be 1 minus 2.205, 0.795. So the question says, what's the probability that you get exactly 3 orange M&Ms? So out of the 8, we have 8 trials. That's the number of draws. And then we want to know exactly 3 successes. So this is a binomial. The way you set that up using the formula is you say probability X equals 3. And you would do the binomial constant, which is this little skinny, it's not division, it's just 8 trials, 3 successes. Your success, 0.205, and that's going to be 3. And your failures, the not oranges, well, that's going to be 8 minus 3 because there's 5 left over. So we can actually calculate this by hand, but I would prefer you just to do the binomial PDF. So this is PDF, probability density function. You do binomial PDF. And we'll do our inputs. So the binomial PDF, go all the way down to this one, option A. And your number of trials is going to be 8. Probability is 0.205. X value is 3. And that's going to be 0.1532. And if you're on an 80 TI-83 calculator, you just do 8, 0.205, 3 when you input that. 0.1532. Which means if you select 8 M&Ms, the probability of exactly 3 of those being orange would be about 15.32%. If you're doing that by hand, that binomial PDF, you could figure that out. That's just 8C3. So if you're interested in knowing that by hand, just go to prob, math prob, NCR, 8 choose 3. And that number is 56. So 56 times 0.205 to the 3rd power times 0.795 to the 5th power. So using the formula, that's where we're at there. All right, next question. What is the probability X is less than or equal to 2? Round to 4 decimal places. So the probability X is less than or equal to 2 is the probability that when you select 8 candies, 2 of them or 1 of them or none of them are going to be orange. So it's going to be the same thing as the probability of x equals 0 plus the probability of x equals 1 plus the probability of x equals 2, right? So we could get those three individually doing binomial PDFs, but I would suggest just using a binomial CDF. So binomial CDF, cumulative density function, everything at that number or below. And then your number of trials is 8. Your probability of success is 0.205, and your x value, so less than or equal to x, is 3. So we're going to input those values for the CDF, not 3, 2. And we'll get our values. Let me do it on the TI-83. So go to binomial CDF. 8 trials, comma, 0.205 is your probability. 2 or less, so it's going to combine the 2, 1, and none of them, and that's going to be 0.7858. 0.7858. And again, you could do 3 binomial PDFs and add them together if you prefer, but that's a little bit less work. And the next question. What's the probability you select at least 4 orange M&Ms? So probability at least 4 is probability at x is greater than or equal to 4, which binomial CDF doesn't do above. So what we want to do is 1 minus the probability of x is less than or equal to 3. So we want to do the complement of that. So we're going to do the binomial CDF here. With your x value, or with your trials is going to be 8. Your probability is 0.205. And your x value is 3. I have that right here. I'm just going to edit it. So CDF for 3 is 0.939. Which means that the probability of getting 4 or more would be 1 minus that. So 0.061. 6.1% chance of getting 4 or more. All right.